welcome to Uptalk. My name is Maja Garde Lindholm, and together with my colleagues Anneli Björkman and Lovisa Svensson, we meet researchers from Uppsala University and talk about current, basic and applied research. During the spring, we will broadcast 2 talks a month on Tuesdays at 12 noon. Uptalk is created to give our alumni and anyone who is interested an opportunity to take part in the exciting work conducted at our university. We are broadcasting live from the recording studio Blåsenhus at Uppsala University, and you who are with us live here today have the opportunity to ask your questions directly in the chat. Send your questions to me and I will see them here in my phone and include them in the conversation. I would also like to mention that this conversation is being recorded and can be viewed afterwards via Uppsala University's YouTube channel and on our website. Can innovation be a solution for sustainable exploration of critical metals and minerals? To succeed in the energy transition and climate adaptation of society, innovative solutions for mineral explorations are needed. How can we create a responsible, socially acceptable, robust and sustainable supply of these strategic and critical metals and minerals? We will discuss this with today's guest, Alireza Malemir, who is professor in applied geophysics and project coordinator for the newly launched Smart Exploration Center that aims to become a global hub for the exploration of critical and strategic minerals. A warm welcome to Alireza.
Thank you, Maja, for having me.
So I thought we should start from the beginning. Can you tell us a bit about yourself and why you chose to do research in your current field?
Yeah, so I'm a geophysicist, so my field of research involves both geoscience and physics. So the reason I chose geophysics was, you can use non-invasive methods to screen the subsurface and obtain information that you would otherwise have to dig in or drill in, as we say it. So, and geophysics is a broad discipline, so you can investigate objects, subsurface, let's call it, from very near surface to very deep in the whole Earth lithosphere and core mantle, for example. So it's very broad, and that's why I like geophysics.
What does a geophysicist do if you look at the difference from geologists, for example?
So geologists typically look at rocks and of course they can look at also soils, but they look at rocks and they try to understand what has happened to the evolution of the rocks, and they can look also into the composition, also the texture, and they can obtain information by direct observation usually. But geophysicists, they don't look at the rocks, so they use the fundamental of physics, and they try to drive information from what kind of rocks is there, what kind of rocks is covered on the surface and in the subsurface, what kind of composition they might have. So basically, we do indirect observation in geophysics as opposed to geology or what geologists do.
So to work in geophysics, you get an engineering degree, or?
Well, traditionally, you could be an engineer, or you could also be a geologist. But if you have a good mathematics and physics background, geophysics is for you. So I would say also sometimes if you're a geologist with good interest and good knowledge in mathematics, you could become a very good geophysicist, because then you have both knowledge that is required to be a good geophysicist. So it's in a way, as I said, it's broad. So you could be geologist, you could be engineer, you could be a physicist, or like me, I came from mining engineering background. So I was an engineer, but you don't really necessarily need to be engineer.
So there are many ways to work with.
There are many ways to come into geophysics. Yes.
Wonderful.
Yes.
So how do you do this? How do you see what is hidden below the surface? I understand that you do use different non-invasive techniques like sonar and electromagnetic measurements using drones. How does that work?
So my field of expertise, it's what we call reflection seismic. So the way we're looking into subsurface is we generate a little vibrational movement, what we call seismic source. And this is where we do it using what we say active sources. So where we have control in the initiation and the power of the source. And what happens to the seismic energy, or what we call a seismic wave, as it propagates through the media, which is in this case is our subsurface, where it intersects different layer boundaries with different contrasts. In our case, it's seismic and density. Then, things happen to the seismic wave. It could reflect, it could diffract, it could refract. So, and we record them on sensors that are, they could also be anywhere on the surface, in a borehole, in a tunnel. So, and these sensors, we have varieties of them. So, when they record the history of what happens to the wave that we generated, and we record them as a function of time, we can then reconstruct what is likely in the subsurface. That's the domain of a seismic exploration. But what happens with electromagnetic is the same. So what you do then, you generate a electromagnetic field, and then what happens to the electromagnetic field, is a function of what kind of resistivity, conductivity the subsurface materials have, and you can then model what is lying in the subsurface in terms of resistivity and conductivity. So in a way, this is what we call the active methods, but you could also use what is already in the earth, like the lightning can generate you that electromagnetic field. So you can then record what we call magnetotelluric. So you don't really need to have active sources. You can use ambient noise in this case, and that's also a field that is very popular now in our geophysics field, but also in mineral exploration. So you can use ambient noise like ocean waves. You can use traffic noise. You can use train noise as your seismic sources.
So you basically listen for these noises
and we listen and we try to tell what they tell.
Yeah.
Yes.
I've seen pictures of people hitting the ground with big sledgehammers.
Yes.
So I suppose that how deep you can see depends on how big the bang is. Do you even use other things like detonations and stuff to get a bigger bang? And how deep can you come into the subsurface?
So, I'm very surprised. You're very knowledgeable. So, yes, when you use a sledgehammer, we say as the deeper you want to see, you need to have a stronger seismic source. So, because your seismic wave would attenuate in the medium, also it will decay as a function of a distance, or in this case would be a time. So if you want to see deep, you need a stronger seismic sources. So you have to adjust to the target you're investigating. So when we use a sledgehammer, and lots of engineering application for construction of a tunnel, highway, airports, runways, you name it. A sledgehammer, it's a good choice. You need to be though strong and you need to stand the hammer. But these are usually enough. If you want to go deeper, we can use different vibrational sources that are engineered for these purposes. And then they can go sometimes they can go to 30, 40 kilometer depth. But if you really want to go very deep, and if you want to do it in a controlled manner, then you might need to use detonation. We have used detonations also in a controlled manner in quarries that are used, to generate gravels for sands for winter. So. But also you can use the ocean waves, and you don't really need to always have sources.
Mm. And I suppose this work is a bit difficult in remote areas, but how you've used drones as well. How well does that work?
So drone is a technology that is very fast evolving in our field of mineral exploration. In our earlier European project, we have furthered this with electromagnetic particularly. So it's very, very popular, especially not only in remote areas where access to helicopter and airplane it's very difficult or it's very expensive. Sometimes also safety is a problem. So drone comes to help you, and it's not going to replace those, but it can help you to give you a first access, or can give you even a detailed access to what's happening in the area that you're exploring. So the beauty of a drone is that you can come close to the surface. If the regulation changes, this is something everyone is watching. If you can actually come close to the surface, because the closer you come to the surface, that means you come closer to the targets, closer to the geology, and then you have a better resolution. It's like your camera, you want to be close to your object so you can get a better picture of it. So and the drone is the same, though I'm now simplifying. So the closer you come in, the better you can resolve your target. And not only that, because drone, as opposed to helicopter and fixed-wing airplanes, they go slower. They can sample more. So in a way, you have higher spatial resolution with drones. And that's what makes it very attractive, not only in remote area, also in places that it's not only in remote areas. I would say it's a technology that is coming very fast, also in accessible places.
Hey, that sounds really interesting. We are going to talk more about exploration, but I just want to start by asking about another application for geophysical measurements. So we know that the geological conditions in Sweden, we have a lot of clay, and we've seen the results of that in form of landslides now recently on the E4 highway. So how are geophysicists involved in this kind of construction of highways and other urban project planning?
I think geophysicists have, in Sweden especially, a number of geophysicists have done a very good job promoting geophysics to be routinely used for infrastructure planning, for studying geohazards. And I think, most likely after flooding, landslides in Sweden is the second geohazard that you could maybe imagine. And you just mentioned the recent landslide. So what geophysicists could do, they could, these landslides are connected to what we call quick clays. And these clays are leached from their salt. And it's a longer story, and I'm not going to get into it. But because they're leached in their salt, they become what we call sensitive. And when you take away salt from the clay, they become more resistive in terms of conductivity. So you just mentioned electromagnetic earlier. So we can use electromagnetic method to say where are this clay leach, and are likely sensitive to become quick, and that's the term is used, quick clay landslides. But also we can use a seismic method to look at the stratigraphy in the clay settings, to see where is water flowing, and it's responsible to leach these clays. So we can provide information about fault systems, stratigraphy in the subsurface, where is a leached clay as opposed to unleached clay. And they're very important. And in the geotechnical world, they drill very sparse, so you can't drill everywhere in the space. And if you use geophysics, you can connect all this, one-dimensional boreholes, and you can get a better picture. And I'm very happy to know that actually in Sweden, this is really pushed now very, very far, and I can see more and more work done. There is a space there, but the improvement is very, very good, encouraging.
So that sounds really reassuring then, because of course, if you know what's in the subsurface, then you can make better constructions and make it safer.
Maja, I want to interrupt here. One thing it's very important. I know maybe we would discuss this a bit. Engineers usually they tack the solution quicker, and I think in the field of engineering, when it comes to landslide, the infrastructure, they really, because you're now talking about money, saving, and environment, life of people, they're more taking innovation. And are ready to embrace the innovation into action, and that's, I think, we see more often in this discipline than others. We get into the mirror exploration. That I think I want to make a background to it.
So the field is really moving forward.
Yes, I would say it's better in a way.
Now, if we're going to move over to a bit more of the mining. Then we know that we do need a lot of resources for the green transition. like materials for batteries, for example.
Yes.
How well equipped is Sweden and Europe for the future when it comes to raw materials?
You know, if you look at historically, Sweden, I mean, the geology of Fennoscandian Shield, you know, the geology that you have in Finland, part of Norway, Sweden, of course, now if you include Greenland and Southern Europe too, they're very favorable because of the long life that this geology has had. It's very favorable to more or less the whole spectrum of these minerals that we need in a daily life. So traditionally, we've been mining for iron. That's made the foundation of a Swedish well-being and also industry, but also base metals, you know, zinc and lead and gold, and, you know, precious metals. But if you now look at it also, you know, in the entire Europe, you really have access to some of these critical raw material. You know, lithium, we've been not talking about this for a long time. So lithium, it's accessible in different forms in different part of Europe. So lithium, you have it in Sweden as a you know, you might have it as a, what we say, pegmatite in Central Europe, where geology is totally different. You have it as maybe as a brine, or you have it as in a sedimentary type basin. So the play is now bigger when it comes to critical raw materials. Some critical raw materials, like rare earths, are very unique to you know, the geology, like the geology Sweden has. So back to Sweden, Sweden really has all the critical raw materials thanks to its geology, and it can really serve Sweden, it can serve Europe, and it can serve the world for the energy transition.
So you have worked with smart exploration in the international context before, but now you're also the project coordinator of the Smart Exploration Research Center that just opened. So what is the Smart Exploration Research Center, and what will you work with?
So basically, you know, what we did back in, you know, from 2017 to 2020, when we had the European project, it was called Smart Exploration. We had 27 partners, 9 European countries, and we learned quite a number of lessons there. And we realized that innovation was really the key drive. And we thought, you know, in order to be really successful, you really need, in mineral exploration, you really need to have a long-term planning, and you really need to also change the mindset. So you can't really do it in a short term, because, you know, you're there, you appear and you disappear. You know, if you make a good legacy, there may be some signature of you for some years. But to be standing, you really need center such, and luckily this was available. And we thought, if we want to make a footprint, we want to really push innovation for longer term, going from technology readiness level of low to higher, to get it to the market, to showcase that it's really working, and it's helping environment, it's helping, you know, it's improving social license to operate. You really need to have that kind of long standing, and the center is a very good a platform to, you know, to leave that legacy, to showcase, to role model that you could use innovation, you can generate knowledge, basic, and also you can generate commercial work while you know, addressing the need for critical raw materials.
So I read that the Smart Exploration project, it will not only include researchers from several Swedish universities, but also representatives from the industry. So how important is it in a project like this to collaborate with industry and also civil society?
It's very important. So you can't just be in your own corner room, and you know, you might be doing very high profile science, but to get the science into action, you need to have an industry discussion. And not only that, these are the stakeholders. If you look at it also, we have very high-tech companies in Sweden that are actually capable of doing things. But you as a researcher, you see the problem, and you discuss it with industry, you see the problem, and you trigger an idea that, you know, we could do this. You know, you ask me, what is the Smart Exploration Research Center? If you could do it smarter, you know, with maybe this is an off-shelf solution, or maybe there is a there is a component of it available, but hasn't been adopted. So if you could do it a smarter way, then you're solving a problem, the great problem that the industry is facing, but also you helping the tech companies to reach out the broader spectrum of client and customers. So luckily, in Sweden we have good consultancies, and these consultancy companies are very good at uptaking the solution from researchers and then passing it to the industry. So in the Smart Exploration Research Center, we don't just have the industry that are end users, but also we have intermediate industry, the tech companies, the consultancy companies, that they really are bridging us. And that bridge was, I think, is for a long time is missing. So we always think of industry should be end user and researcher. We don't think about the intermediate components, and sometimes the European Commission calls them small and medium enterprises. So we have that also component that we can reach, we can use them to reach industry, while we're also talking as a group in the center.
That's really interesting, because you are kind of part of a larger value chain where everything from the battery manufacturers who need the metals, to you do the prospecting, to the mining companies, so it's part of a bigger system.
Yes, absolutely. And you just touch a point. In our center we also have a nanotechnology group that will be working on optimizing the sort of a filter that could help to extract what you don't really want, but in a cost efficient and environmentally friendly way. You sometimes have elements that are really not useful, and you want to really remove them away from your processing. So we have also nanotechnology in our discipline. So the center has this big synergy that helps us to go from the full value chain, is to go from exploration, the knowledge that we have, get it to the level that we can even tell how we can extract these critical raw materials.
So which metals will you, or raw materials will you be searching for then in this?
So basically, European Union every few years they publish a list, and this list is growing, and soon we will have the whole table of elements. So they publish what they call critical raw material, and recently they had another term called strategic metals, and the strategic metals are usually the one that the Commission sees them as important for energy transition, like copper, for example, nickel. Why they are maybe abundant, but they have a longer value to reach our goal. So this list contains rare earths. So we will be looking at rare earth elements, heavy and light ones, and amazingly, some of the iron oxide deposit, the iron deposits, iron mining that we have, they have these rare earth elements, and we've been overlooking at them. There has been messages and news. Some of the big mines in Sweden, they have a big amount of REs. But we're going to look into different deposits, different types of these iron ores, and see what quantity is there and what made them to be enriched in REs. We would be looking at lithium, graphite, nickel, copper. We will be looking at vanadium. We will be looking at tungsten. Some of these as a direct commodity. Some of them are associated with a bigger deposit, like it might be a massive sulfide that you have lead and zinc, but on the side you have other commodities that are very critical. One thing we would be also looking in why we're searching for these metals, we're not only looking at where you can find them, but rather where how they were formed. And that's where the geophysics play a big role. If you just close your eyes to your target, you sometimes fool yourself. So what we do, geophysicists, we look back and look at bigger picture, and we see what happened to the earth and why we get these deposits where they occur. And could we learn a message? Could we map it? Could we could be footprinted, fingerprinted in this subsurface and predict where other big deposits are sitting. So, and that's also one of the key work of this center.
So then you can make it easier to search when you already know where to look.
And we can also use that lesson globally for maybe expand it to other places.
So what do you see in the future for this center?
So I really, my hope is that the center would be a fast track hub, and pharma industry, in terms of risk, exploration has a high risk, and you talk about the expenditure is a big problem. Companies and investors, they don't want to put so much money into exploration. But, pharma industry, they manage to convince investors that, if you invest in tech and you embrace innovation, they pay off. And we hope this center would be a fast track. So we don't sit and wait necessarily to see the problem from the industry, but we predict the problem. We maybe predict what kind of critical raw material will come in, and we try to develop solution beyond. And now the center is long lasting, so we shouldn't be just looking for today. We should be looking maybe 5-10 years what happens. And I hope that this center would be a fast track that is ready to immediately take problems if the problem occurs. We had a corona time, and the science was there, so we quickly got a vaccine. So if we think of it the same way, and we are ready to, predict what's happening, we can develop solution for mineral exploration also for future.
That sounds really exciting. Now, one thing that comes to mind talking about mining, of course, is the ethical and environmental questions. So mining does have a bit of a dark history.
Yes.
With pollution to water and air and some colonial mentalism as well. So how does your project work with these questions?
So if you look at if there is, we say it, we have said it in many of our present, if there is one obstacle to not meet the Paris Agreement, the energy transition, going to electrical vehicles, electrification, is if we can't address the social license. And because if you can't address the social license, if you can't get the agreement of public, why you have to do what you need to do, you're going to be behind the climate goals. And I think it's very important that when we start exploration, is the first stage of a bigger process. At the exploration, you don't have so much footprint. You can make a footprint, but if you do it right at the exploration stage, if you show that you're minimizing the environmental footprint, you may be removing it if possible, you're effective, you communicate, you're transparent, then you can make a next step, and this is our goal. So we have a big component. We have 4 hubs in the Smart Exploration Research Center, and we have a few work packages that they deal with what we call ESGs, and that's environment, social, and governance. So we want not the way we operate the center to meet all the ESGs, but also the activities and the communication we have with the public. They're very much aware that why we do exploration, why we need mining, and how we can do it better. And I'm very much aware of quite a number of failures. But we need to be better, and we can be better. And I think innovation can help us to be better and minimize, also, clean up a little bit of the bad picture mining and mineral exploration has.
Now, also considering the United Nations will publish the Global Resources Outlook for 2024, probably on Friday. And I read in The Guardian that they're going to say, among other things, that we need to define sustainable use of resources. So how much is enough when it comes to exploration? Is there a point where we should rather limit our demand instead of increase exploration?
It's a very good question. At the end of the day, you want to come up with a strategy that, we're talking about circular economy then, when would it be a time that we don't really need to mine? Or should we just invent materials that that we don't really need to mine? There is actually saying in the mining industry that if you can't farm it, you have to mine it. So it's very known that and some of these commodities, you know, I'm just telling you that the list of critical raw materials are just growing. That means we're getting more and more diverse in terms of what we need and the technology that is moving. So do we want to stop technology? That's one thing. But as we move with technology, or need for these diverse elements that's growing. So that is there. We can't really avoid it. Plus, to get to the circular economy, we must already have something, you know, we must have produced. We haven't even produced. So we talked about electric cars. And if you look at the demands for electrical cars, there is nothing we can now recycle because we haven't even touched them. So we need to make that step now, and I think it's fair that we need all to think about how do we, you know, do it sustainably, and there's recycling has to be there, to tracking of how it's produced. You know, we do have that with textile industry, with, you know, coffee. Now we know where we get the coffee from. So why not with metals? You know, where do we get them? Are we get them in a sustainable? Should they have a tag? Should they be a and I think these are all sort of things that the mining industry is looking at. We in the center will look at, and we try to come up with pilot works and ways to address it.
Feels like we could talk about this for a lot more time, but
unfortunately, it's you know, the demand it's there, and I'm afraid that the only way for short term is to make sure that we're doing it in the right way.
Yes. So our time is unfortunately up, so we won't be able to discuss this more just today.
Yes.
But in 2 weeks' time, on March 12th, we will meet Nina Kivinen, who's a senior lecturer and program director at the Department of Civil and Industrial Engineering, in a conversation about organizational research, creative work practices, and the importance of unexpected encounters. And that conversation will be in Swedish. So don't miss it. And thank you very much, Alireza, for today. And thank you all who came and listened today. And welcome back in 2 weeks.